everyone. Welcome to the state of media playback. We'll be talking today about how to do media playback the right way. So things have changed quite a bit over time from the earliest Android days to now, but we've come up with a pretty good solution on a lot of the things you actually need to do to really get the best experience out of media playback. And so we'll be talking through a lot of the best practices around all of that. A little bit about me. I've been doing Android development for about 5 years now. Started doing it in my spare time and then moved to doing it full-time, first at Funware and then at Facebook. And now I work at Google as a developer advocate. So I'm working on both the Advanced Android Udacity course, which is online learning to get your learn on, as well as a new Android development patterns series of kind of going into all of these best practices. My focus has primarily been on the framework and the support library, and I actually work really closely with the media framework team as well to write a lot of these things I'm going to be talking about. Now, media playback can mean a lot to a lot of different people. So today we're going to be focusing on just one part of that, specifically audio playback. Believe me, there's enough in the land of media that we could cover a whole presentation, a whole conference about it. But for this, we'll be focusing solely on audio playback. For video, you might consider looking at the Cast Companion library. It's up on GitHub. It's actually a really good example of a lot of the best practices around video playback, especially with interacting with Google Cast devices. So when we talk about any app, right, we really want to start with the user, right? They are the most important part of the app. It's really our job as developers to give them the best experience that we can. And that really starts with what they're expecting from your app. Right? That starts with the description and screenshots and goes into the actual functionality of the app. And what we're trying to do is rather than just meet those expectations, we're really trying to exceed those expectations, right? The worst thing that we can do to users is have them expect that, oh, this is supposed to do this, but then all of a sudden your app, unlike every other app, doesn't do it the right way. And for media apps, especially for audio playback, there are a lot of things that do come as kind of preconditions and expectations from the user. And, of course, for audio apps, the first user expectation is really background playback. I don't know if you've ever had a media app that you hit the home button and it just stops playing, right? Even for video apps like YouTube, for example, now they also support kind of that background playback. So for audio apps particularly, this is kind of one of those base requirements. And when we think about background playback, we should really already be thinking about services. Right? These are the top-level Android component specifically for doing work in the background that isn't tied to an activity or a short-lived broadcast receiver. So it really is kind of the natural choice for handling all of our media state. So what actually goes into media playback at just kind of the 10,000-foot level? A lot of this comes down to kind of this super simplified version of kind of the events in media playback. So for every service, right, that's running, eventually it's going to be created, right? This may be the start of playback or when your app first gets created, but we have some one-time initialization in the created step. And then eventually when the user actually hits that play button, that's when we're going to go into the playing state. And playing state here really means any time when we are actually outputting audio, right? So this is slightly different from the pause state, which would be the reverse of any time that we're ready to play or getting ready to play, but not actually playing any music. So from a play-pause perspective, obviously, for any audio app, we're going to want to be able to transition back and forth between those states. But at some point, the user is probably going to stop playback. This may be something like swiping away the notification or closing your app or rebooting their device or what have you. In that case, we're going to move to the stopped state. And this case is really the case where we're explicitly closed and we can generally remove all of our information and say, hey, we're done playing back. and where we were going to then transition to the destroyed state, which is where we do kind of that one-time cleanup state of releasing system resources, stopping our service, that type of thing. There may be some difference between stopped and destroyed, and we'll get into that. So it wouldn't be much of an audio app if it didn't actually play audio. That's kind of a big part of it. So we'll be assuming that you're using something like Media Player, which is built into Android, but the same talk works actually extremely well if you're using something like Exo Player or any other third-party playback system. All of this is kind of agnostic to that, and really kind of building on top of that to say, like, okay, well, beyond just let's play some audio, can we do a little bit more? But for Media Player, we can see it as a pretty easy, straightforward flow for our different event states, right? We'll create a new media player, and then, of course, we'll prepare and play. When we go to playing, we'll pause. When we pause, we stop. When we stop, right? This should be fairly straightforward from a media playback perspective. And well, we're done. Media plays, pause, and we have lots of time back for getting ready for lunch. But maybe we should go into a little bit more detail. So we're really trying to do it the right way, right? In fact, just playing audio in the background with no controls, no information, and no idea of what the user's doing is probably actually a net negative for the user, right? And we want to get onto the positive side. So what can we get to really kind of bump this up to at least an acceptable experience, rather than something that is just blasting music from your phone with no controls in the background that they can't control and have to find your app to kill it? Probably not the best place to be. So the first thing we want to do is audio focus. Now, it really is one of those keys of being a great citizen on Android. So it's the way of getting kind of that heads up to other apps and to the system that you want to play something, right? That you are ready to play, and at the same point, it also means that someone can't necessarily take your audio focus, right? What we don't want is we don't want multiple apps playing back on top of one another and causing issues where you can't understand either one of them. Now, this is slightly distinct from actually playing audio, right? It's the intent to play audio. So we'll want to continue to have audio focus anytime we're ready to play or going to play or really taking on that role of the main media playback in an app. So we can look at some code like this to request audio focus. We'll use Audio Manager for this. And then actually going through and requesting audio focus, right? In this case, looking for the stream music, right? The main playback stream for audio playback, and hoping to gain audio focus. Now, one thing to note is that almost all of the time, you'll be granted audio focus. But there are a few exceptions where you'll actually not be granted audio focus. One example is maybe when the user's in a phone call. And that probably isn't the time to start blasting music because they're actually talking with another human, which is great. But it means that our media playback should probably just abort and say, you know what, like we didn't get audio focus, so we shouldn't continue. But most of the time, you'll be able to proceed and play your glorious music. And then, of course, we need to abandon audio focus when we're stopping playback, right? When we get to that final stopped state. But what is that audio focus change listener thing? I just put it in here for no reason. Well, it's actually how you learn from other apps what's going on in the system, right? It's your link to other apps and to the system saying, like, well, someone else is requesting audio focus. And how does your app actually react to that? It's the callback system. So you may be getting an audio focus loss. Now, this is pretty serious. This means that the other app is taking over permanent control of audio focus, at least while it's the last one to request it, and your audio focus isn't coming back. You're done. It's not your turn yet. So in this case, we'll want to move to the stopped state, right? You're kind of done playing back audio. They've moved on to a different app. Now, one thing to consider is that maybe you don't want to immediately remove notifications and delete your service and everything immediately upon audio loss. You could decide to wait around for 30 seconds just in case they accidentally hit the wrong app. But this is really kind of one of those user experience things where you should test with your users on what they expect when they accidentally hit another app. For most Google apps, when they do lose audio focus, you'll see that they immediately stop playback and await any future concerns. Now, there's another one called loss transient. Now, in this case, it's not a permanent loss. It's just a short-term loss. So this may be a case where you're using something like Google Maps, and it's announcing like, oh, you're going to be on time, right? A temporary loss, but you can expect it back. So in this case, loss transient means you should just pause your media playback. Now, there's the other one you may be very familiar with, which is the loss transient can duck. Now, this is the basic when like a notification sound comes in, right? And in this case, the expectation is that you're going to lower the volume. You don't necessarily need to pause completely, but you just lower the volume so that the other sound can be heard clearly, and then you'll regain audio focus with audio gain. Now, one thing to keep in mind with the can duck is that you don't have to lower your volume. You can actually pause. Like, for example, if you're a podcast playing app and you're having spoken words, it's very important that the user hears everything that's going on, and maybe they don't want Google Maps talking over them. You can actually pause for any of these events, right? And then resume when you get audio gain. So there aren't necessarily requirements to do anything, but in any case, you should be respecting these audio focus changes. So what is our updated lifecycle? So we can see here now we're requesting focus when we start playback, and we're removing focus, abandoning focus, when we actually stopped. Now note, this isn't tied to playing audio or back. And even with just this, we already are a lot better citizen and working well with the system and other media apps. But are we done? We're done? No. All right. So more to go. And that's fine, because these are important things that users are going to expect. Now, one of the things, and probably my favorite named broadcast, is the becoming noisy broadcast, which is kind of exactly how it sounds. It's actually when you're listening to something on headphones or a Bluetooth headset, and the Bluetooth headset runs out of batteries, or the headphone gets yanked out, and all of a sudden it's blaring to the whole crowd, to the whole audience of, wow, that's really what you're listening to right now. Probably should have used becoming noisy to be able to pause your playback. So it's a really nice way of saying like, okay, well, the user is expecting that they are not blaring out their music to everyone, and we can register a becoming noisy broadcast very simply with register receiver, and then of course unregister it. Now in this case, because this is tied to not wanting to blare music out to the world, these events are going to be tied into the actual playing and pause state. So only when we're outputting audio are we going to want to register for the becoming noisy and then unregister when we actually pause playback. So slightly different here. And actually at this point, we're in a fairly decent state. We're never going to be playing audio when the user is not expecting it, and we're going to play well with other apps that are doing notifications or other things. But we're not quite to the best media playback experience. In fact, we haven't talked about controls at all. And it's certainly one of those very frustrating things when you're trying to find the pause button or the play button or the next track button, because that track isn't appropriate for everyone who's in the car. And you want that control available as many places as possible. You don't want to have to dive into an app and find it in your recents or what have you. So thankfully, Android offers a lot of ways to actually get controls everywhere. And one of the ones that's most frustrating at work are headphones and Bluetooth controls. The times when you're really listening to music and you don't necessarily want to pull off your phone, and they have buttons on them now, so we should probably get those working. And collectively, these are called media buttons. In fact, they're just like any other button that is hit on the system. They're key events that are sent to the system and onto your apps. And by default, the system is actually going to capture all of these and then send them out as a media button broadcast, which of course your app can then receive and handle. And you can build just a simple broadcast receiver that then extracts a key event and then does work on it. And we found that basically all of these receivers were doing the exact same thing, right? They need to look at a key event and then extract from the intent what the key event was and then somehow transfer that to our service. So we built it all for you. We built a media button receiver in the support library, version 23.1 and higher, so that it kind of handles a lot of the boilerplate for you. How does it work? You have no code whatsoever. It's just a few manifest entries. You'll add it to your manifest. You'll note our media button intent filter here. And then, instead of writing all the code yourself, what it's going to do is it's going to look for a service that's also in your manifest that has that same media button intent. And what it'll do is every time the broadcast receiver receives a media button intent, it'll forward that on to your service, which makes it really nice because in your service that has your media player and that type of things, you can actually act on those events. The big problem we found was that in so many times, you'd want the broadcast receiver to see, oh, you hit the play pause button, or you hit the next track button, and now all of a sudden I need to somehow get that to my service. And this really helps in that common case. So one problem though, if you add this code, it won't actually work. Thanks, Ian. But it turns out that this is an important thing for all of Android, in that there's what's called a preferred media button receiver. In fact, it's probably not a very good idea if every media app on your phone all received every media button. First, we'd have many, many processes starting all at the same time, as well as, of course, there's usually only one app that has autofocus that wants to play back apps. That is actually the one that is the preferred app. So it's very similar to autofocus in that it's a last wins kind of model, right? If you're the last one to say, I want to be the preferred media button receiver, then you'll become the preferred media button receiver. So if you've ever had like play music take over when you hit the play pause button or when you get into your car, that's usually the app you were expecting, not actually handling being the preferred media button receiver. So if all apps do this correctly, then when you do get in your car and your Bluetooth auto connects and it starts playback, it's actually going to start the app that you actually last used rather than the one that was just last registered. So, and that's really where Media Session Compat, another class, comes in. It's really that consolidated connection between your app and the system. And it's actually doing a lot more than you might imagine. So we built the Media Session APIs in Lollipop. And Media Session Compat brings that back to every app, even down to V4, if you're that person who's still supporting V4. Please, no V4s, right? V8, maybe? Everything cool in media starts at about V8. So we're covering everyone with Media Session Compat. And it's actually doing just about everything for you with just a simple few methods. But of course, we do want to create it, and there's one thing you want to do especially is make sure you're setting flags. You want to set the both media buttons and the transport controls flag. This is what actually allows some of those connections to your app. Now, if you're doing like a very temporary thing, like say showing an advertisement that probably shouldn't have these actions, those flags are actually a really good way of turning those off temporarily and then turning them back on. But for the most cases, for media playback, you'll want to just always set those two flags. And then we have this concept of callbacks. And these callbacks are really the on play, on pause, basically all of the events that your app wants to respond to. And what we'll use our callbacks for is kind of the main way of interacting with media player. So everything that's coming into your service, everything that's coming into your app, then goes through one of these callbacks to actually then trigger the media player. The nice part about this solution is that it works really well if you do want to enable cast in your media app, because you can just switch out your callbacks and switch from local callbacks to remote callbacks and not have to actually touch any of the rest of your code. Just have on play and on pause do a different thing based on whatever the current callback is. So The one thing we actually need to really do then to become the preferred media button playback is called set active. And we'll set active to true. Basically, at the same time, we're requesting audio focus, and we've been granted audio focus. And then set active to false when we actually stop. So this is kind of the important part that's actually going to get us to the preferred media button receiver. And you'll note that once we call these lines, then magically all of our broadcast receivers start working. This is also the exact time where we can use media button receiver's other handy method, which is handle intent. So this handle intent takes in your media session compat, extracts the key events, and then hands it off to your callbacks, all without having to write any more code. It's just one line in your on-start command, and all of a sudden your callbacks are then receiving media button events without you having to write or decode key events to get through all of that. Now, there's one wrinkle, though, because how does it know that when you hit the play pause button on your Bluetooth remote that you want to play or you want to pause, right? We haven't actually told you what's going on. We haven't told the system anything. So that's what playback state compat is for. It's actually how you tell the system what's currently going on. And there's actually two parts to it. One is set state. So this is what's currently going on. So this is like state playing, state paused, buffering, as well as kind of your position. So if you're 30 seconds into a track, you'll set the position to 30. The other part is set actions. Now, set actions are what controls we support. So you'll definitely want to support, say, play pause and stop. But of course, if you support skip to next or not, those actions are actually going to be really important to set here. If you don't set those actions here, you won't get media buttons for them, and you won't get controls on Android Wear and on Android Auto as well. They all rely on kind of those actions to be set. So if you want to support rewind, again, one of the actions you need to add. So these are kind of actually grouped together because many times they change at the same time, right? If you are buffering, you probably don't have a fast forward button. If you're paused, you probably don't have a pause button, right? You'll want to switch the actions at the same time you're switching your state. But what about those cool lock screen controls? We added them in Ice Cream Sandwich, and you could play pause without unlocking your phone. It was probably the coolest thing, like except for the whole combining phones and tablets together, but that's not important for this talk. And it's actually pretty easy. It requires a little bit of metadata, in fact. A picture, right, would kind of be required for this information. Now, this is actually used for a lot more than just lock screen controls. Like Android Wear will take the background image from your metadata. So what kinds of metadata? Well, there's actually like 27 different kinds of metadata you can add. These are kind of the most important ones, the ones you'd expect. Title, album, artist, album artist, if that's a different thing. As well as the duration, right? That goes really well with that position. We added it in playback state. As well as the actual images themselves. You can store them as bitmaps or provide URIs to content URIs, which then the app can read. Now, really, really don't store like 4,000 by 4,000 pixel bitmaps in this. These are sent to other apps. So if you're doing it, you probably want to set a smaller image in a bitmap and then provide a URI for the full-size image in case apps really do want that level of information. So how does this actually work with our playback, with our life cycle? Well, we'll want to create, set flag, set callback on create, and then set active, make sure our metadata and state are updated when we start playing. And then, of course, when we pause, we'll want to update our state. Stopped, we'll set active to false. Right, similarly, again, along with our audio focus, and then we'll release when we're all done. So lock screen controls, like how old are those, right? We actually removed all of them. So in fact, notifications are the new hotness for the lock screen. And in fact, we probably should have been using notifications all along. They're kind of a big deal. It doesn't really make sense to lock your phone just to get to media controls. So having notifications actually turns out to be really useful. But writing a custom notification that does media controls and have it work well on every device is actually really hard. So we built it for you. We backported kind of the media style notification, which was added in Lollipop, so that now you can use it on all platform versions. But that did come with a few caveats. First of all, prior to API 14, you couldn't actually have buttons in your notification. It's just one-click target. Like, can you imagine? Like, it must have been horrible. But we've moved on. But thankfully, media style will just continue to work. It'll give you the best effort it can at that level. On API 14, we actually can add actions. So you'll note there can be up to 3 actions in the collapsed view, that single line view of the notification. API 16, Jelly Bean, added expanded notifications, where now we can have up to 5 actions. And on 5.0 and higher, we'll just use the framework media style. So as we change things and things get even better, or the styling changes, you'll always know that you are in sync with the framework at all API 21 and higher. So I don't like writing boilerplate. I'm sure many of you love writing boilerplate, right? Boilerplate? No? Wow, you all hate boilerplate too. So it's OK, I wrote it for you because I want you guys to save as much time as possible. And so I built this helper that actually takes a media session compat and builds a notification for you. And it all relies on media metadata's get description. So get description actually looks at all of those metadata fields that you've added and extracts just the most important information from it. It turns out that it extracts the same information, the same fields that I already talked about. It's like I planned it that way. But there's actually display-specific metadata items if you want to specifically override this case, because this is actually what Android Wear is also going to use. But once we have that description, we can actually build most of our notification directly from that description, getting the title, the text, and any subtext that's available, as well as a large icon in the actual icon itself. We can also actually fill out other things, like the click intent for going through. As long as we call set session activity on our media session compat, we can then pull it out for our notification. Additionally, in Lollipop, there's a concept of hidden notifications, right? You may not want all of your notifications on the lock screen all the time. So for these notifications, for media controls, you probably want to set them to public. That way, people can interact even if they've chosen to hide their other notifications. And then, of course, when the notification is actually removed, swiped away, we'll want to stop playback, right? We don't necessarily want the user to continue to hear music when they've specifically swiped away our notification. So you'll note we actually use a different one called get action intent. And that's actually fairly easy. It's basically me faking what you'd receive as a media button, building our own key intent, and then building a broadcast. That's just going to trigger that same media button receiver, going to your service, going to your callback. So again, you don't need to write anything more of all this. So I actually have a gist available of all of this code, so I'm sure you're furiously writing. There must be someone furiously writing. No, you're just working on your laptops. It's fine. It's fine. I understand. So let's actually build our notification. You'll still need a small icon for the status bar. And there's one thing that's slightly different about media style notifications in that the color, rather than just affecting the small icon, is going to fill the whole background of the image. So bright orange, not a good idea. Generally, you want to use something branded for your color. The primary dark is actually a really good example of something to use, but you could also use a more neutral color. By default, it'll default to a gray color. So it wouldn't be much of a media notification if it didn't have any actions. So I'd say a play pause action, and then actually use our get action intent to help us build the pending intent that we need. And then we'll actually call creating a media style. So this media style actually requires that we then choose which actions, 0 indexed, you want to display in that compact view, that single line view. In this case, we'll show our play pause button, right? Because that's kind of useful, right? But you may want to show, say, a next track button is a really good example of something you may also want to show in the compact view. And then we want to set the media session. So this session token is actually really critical to get things like Android Wear working. So Android Wear is actually going to use that session token to pass callbacks to you on Android 5.0 and higher devices. So if you forget this line, you get a great notification that appears on your wrist, and you'll hit the play pause button, and it won't do anything. And your users will be so frustrated. So thankfully, it's just one line. It's super easy to add. Just make sure you add it. So lifecycle-wise, here we're showing our notification. When we start playing, we'll pause it. When we we'll update it when we paused, anytime we're changing the state. And then, of course, when we stopped or destroyed, we'll want to clear the notification. Now, one thing you might consider here is sometimes it makes sense to actually keep your notification around just a little bit longer before you actually stopped in case the user wants to restart. Say they reach the end of their playlist. So don't consider it necessarily a hard requirement to remove your notification, but in all cases, you should consider maybe a timeout kind of a system. So media playback is actually one of the things that's actually going to be a really good candidate for foreground services. Foreground services raise the priority of your background service such that it isn't killed in only the most extreme memory conditions. So this is great because it's super noticeable when the media playback app is killed in the background because media playback stops. So foreground services have a requirement that you have a notification. And thankfully, we just built a notification, so it should be fairly easy to get this actually started as a foreground service. Now, there's one caveat, though. Prior to Lollipop, if you call stop foreground false, you actually can't swipe dismiss the notification. And this is actually a really common case in media playback apps, because you don't necessarily need to be a foreground service when you're not playing audio, right? In theory, in the most memory hard areas, you'll probably not want to be a foreground service when you're stopped playback. So how do I work around this bug? We fixed it in Lollipop, but that doesn't help people who are not Min SDK 21. Anyone? No one lucky here. So MediaStyle kind of built something for it, a cancel button, a simple X in the corner that allows users, even prior to Lollipop, to remove your notification even though they can't ever swipe it away. So actually extremely easy to add. You'll call set show cancel button true, and then add the intent to then stop playback. Now the nice part is because we fixed it in Lollipop, these calls won't actually do anything on Lollipop and above. They're just only for backward compatibility reasons. On Lollipop and above, as soon as you hit pause and you set your state to pause and you stop being a foreground service, you can swipe away the notification without a problem. So we've updated our notification. Now we're going to start foreground, stop foreground false to keep the notification around, but not be a foreground service, and then stop foreground true to remove our notification when we've actually stopped entirely. And actually our services, this is about everything. Like, it's a lot, but we've actually handled all the things that our service can handle. There's just one thing we still need to do, build a UI, right? Like, that's kind of a big deal for most media playback apps. Maybe if you had like a single radio station, that would be really boring, but you could maybe get away with it. So we have to figure out some way of connecting our service to our UI. And ideally, we'd like to reuse all of those callbacks on play, on pause, on stop that we already have in our service for hooking up our buttons to it. So we built one of those. It's called Media Controller Compat. And it's actually the way of once you connect, you can actually get all of the current metadata. So you can update your UI to say what's currently playing. You can actually get the playback state, so you'll know, hey, are we playing, are we paused, are we buffering? So you'll be able to update the UI based on those actions. And then there's also a transport controls callback. And here it actually gives you kind of that one-to-one, so it has methods like play, pause, skip to next, that directly correspond with the callback we've registered in our media session Compat. So you can very easily hook up then your play button to transport controls play, and you're done. There's no additional communication steps you need as soon as you have a media controller Compat. There's one thing though, you actually need to get a media controller Compat instance. And to do that, we're actually going to use that same session token that we added to our notification. We just somehow need to get that from our service to our UI. So there's a really nice class that does that too. It's like we thought of everything. It's called Media Browser Service and the Media Browser. And when you create a media browser service, rather than just a service, it actually gives you mechanisms to connect to your service from your UI and then retrieve the token, as well as get new APIs, which, you guessed it, allows you to browse media on your device. So this may be able to easily build out your UI based on, say, a list of tracks or a list of albums and any other kind of things you want. This is actually required for Android Auto integration. If you think about Android Auto, you don't have control over the UI itself because of car safety, but you do have control over what audio tracks appear in your media playback, and that's all done through Media Browser Service. It also adds a browse action on Android Wear, which if you scroll all the way over from a playback action, you'll see a browse button. You'll actually be able to select the next track directly from there. So it's really simple to actually use Media Browser Service. Instead of extending service, you extend Media Browser Service. And then there's just one method to do set session token in your onCreate. This is what ties in that session token so that your Media Browser Service knows, all right, well, what is that token I need? Of course, there are the new methods onGetRoot, which is kind of the root of your whole application, as well as onLoadChildren, onLoadItem, which you could expect loads a list of tracks or a single track. And we actually have an example, the Universal Android Music Player, UAMP, which goes through this entire flow and has a lot more code. It goes through basically everything we've talked about here today. Now, one downside is that Media Browser Service is API 21 and above. So we're actually working on backporting it right now. We have a version that works. It's going to be in the next version of the support library. But if you can't wait, there's a few things you can do in the meantime. Because remember, all we need is just a token in our UI. So we could actually just use a static method and called getSessionToken, which then retrieves the token, right? If you have your favorite event bus application of choice, there's certainly very many ways of getting a random item from one to the other. Do note that the session token is parcelable, so you can send it over broadcasts or between processes without a problem. The other choice is to kind of build a media browser service light, basically do your own binding to the service, and then actually just have the get token as part of that binder API. So it's a little bit more complicated to get through that, but we have a nice article about bound services if you're interested in going through that approach. Well, and so that's about everything. This is the slide. I could have just given to you this at the beginning, but I would have felt a little anticlimactic. But this is actually everything that we need to get our service to be doing literally everything it possibly can to give the best user experience for our users. That means playing well with audio playback, having controls everywhere possible, using notifications and using a foreground service to make sure we're not killed in the background, as well as doing Android Wear and Android Auto integration so that your media playback works perfectly everywhere. So if you have any questions for me, feel free to reach out to me on Google+ or Twitter. Happy to answer your questions. Thanks again.